Okay, last point of section 2. To find length of tangent from external point to a circle. So we need to find length of tangent. So length of tangent means if you take any point, external point of the circle, from that point we need to find length of tangent, that is what is the point of contact. Looking here, P is the point. If suppose A is the point of contact. In previous we are discussing that definition. From the definition, it is a secant. The line intersect the circle at 2 points is a secant. Tangent means if a line intersect at if a line touches only one point of the circle, only touches the circle at one point. That meaning is the secant is converting into tangent means the 2 points are coincide to each other. The point B is coincide to each other. The point B is also coincide to each other. Then it becomes the tangent. In the previous we are discussing that is the tangent definition and secant definition. By using the theorem, this is method 1. We need to find length of tangent by known theorem. So what is the theorem statement? PA into PB is equal to S11. In the previous theorem we have proved this one. The distance from point to A and point to B, the product of the two distances is nothing but power of the point S11. So now P to A is the distance from point to A, P to B is point to B. But if suppose both are equal in the tangent notation, the tangent form, A and B both are equal, that is coincide. Coincide means here A equal to B, that is PA into this is also PA is equal to S11. So that is PA square is equal to S11. That's why PA is called length of tangent. It will become root S11. So root of the S11. So S11 they are taking a square root. That length, the result is called length of the tangent. So from the theorem you can prove this one. Root S11 is the length of tangent. Is the method 1. We are going to find one more method. Method 2 also. I am arranging this. Method 2. I have seen here is the tangent is the point A, is the point required point P is x1 y1, is the point of contact, is the center C is a perpendicular, right. So look at this diagram. A is the point of contact to the circle, P is external point to the circle, C is the center of the circle. Now we need to find P to A distance, PA. So we need to find PA distance. What is the PA distance? It's a right angle triangle. In triangle CAP, angle A is 90. Then we can use the Pythagoras theorem. So by using Pythagoras theorem, so what is the Pythagoras theorem statement? Hypotenuse square, that is PC square or CP square. CP square is equal to CA square plus PA square. CP square is equal to CA square plus PA square. These are generally by using Pythagoras theorem from the right angle triangle. Why? Because the point of contact taken as 90 in the previous we know in the lowest level. A is the point of contact to the circle, C is the center. The line drawn from center to the point of contact making as 90 degrees. You know that basic thing. That's why it's a right angle triangle. CP square equal to CA square plus PA square. Now CP square is equal to CA square means radius R square plus PA square. Now it shift this side. CP square minus R square is equal to PA square. So in the previous we know this value CP square minus R square, the power of the point. The power of the point Cp square minus R square is nothing but power of the point S11. In the starting point we are defining this one. Cp square minus R square. The difference is nothing but S11. So that is S11 is equal to PA square. That's why PA is equal to plus or minus root over S11. So distance is never negative. That's why you are taking as the length of tangent from point P is root S11 is the length of tangent formula. Okay, I will see. Either method 1 for either theorem, or method 2 you can establish that Pythagoras theorem to derive the length of tangent PA is equal to root of S11. Nothing but is the square root of power of the point. The power of the point which is the outside of the circle. Have you seen once? Okay, just overlook the section 2 all points conclusions. First one, Cp square minus R square is nothing but S11. We are defining that S11. The condition for this S11 is greater than 0 or equal to 0 or less than 0 is nothing but position of the point. Position of point. That S11 S11 is equal to something. The result of otherwise the value of S11 is called as power of the point. Depend upon S11. What is the relation? S11 is either 0 or greater than 0 or less than 0. That is nothing but position of the point. You can say the position of the point by comparing 0 to S11. If the value or result, what is the result getting of S11? That is nothing but power of the point is same. And root over S11 is called as length of tangent. So these are the points we are getting in section 2. So ultimately, and theorem and definition of secant tangent are no need to write again. Just these three only we are following in this section 2. So by comparing 0, law of trigonometry like this, like the law of trigonometry above 0, below 0, equal 0 like this, and the result or the value is called power. Root of this S11 is nothing but length of the tangent to the point from the circle. Okay. Let's see some example questions. Okay, let's see the example. Is given point 3, 4, circle x square plus y square minus 4x minus 6y minus 12 equals 0. We need to find all the things in here. First of all, S11, we need to find S11. S11 means general thing. S11 is x1 square plus y1 square minus 4x1 minus 6y minus 12 equal to 0. So now substitute the point. X1 means 3, y1 means 4. Let's substitute here to get the condition for S11 is 3 square plus 4 square minus 4 into 3 minus 6 into 4 minus 12. So that is 9 plus 16 minus 12 minus 24 minus 12. So now it is S11 is 9 plus 16 25. 25 it is minus 48. So definitely it is become negative number, negative value that is. So how much that is value? Minus 25. So plus 25 it is, that is 24. So it will become means 123 minus 23. So minus 23 is a negative. So first one, S11 is less than 0 and S11 is equal to minus 23. So root S11 is not real. That's why not exist. tangent not formed. So tangent not formed. So over conclusion over depend upon three conditions. So S11 is minus 23, that's why less than 0. S11 is less than 0, the point inside the circle. The point inside the circle. So S11 is minus 23, so power of the point P is minus 23. So S11 is negative, that's why root means it is getting imaginary. So imaginary means that's why no tangent will be formed from the point P. Why? Because if you draw a line through P, it will become secant, not a tangent. So that's why tangent not formed. So this is the given point circle. You can conclude by using three conditions as it is at a time. Okay. Let's see the second example. If the length of tangent from the point to the circle is root 37. So length of tangent is already given root 37. Then find k value. So what is the condition? Length of tangent PT, just we have taken PT bar is equal to root 37. So length of tangent means S11. Root S11 is nothing but root 37. Root S11, that is root S11 is nothing but root 37. So root of squaring on both sides, the roots will be cancelled. So S11 is equal to 37. Just check the point. S11 means is the point P 2, 5, that is x1 y1. So the circle equation is there already. S value can replace that directly. That is 2 square. Y1 means 5, that is 5 square minus 5 into 2 plus 4 into 5 plus k is equal to 37. So now it is 4, 25 minus 10 plus 20 plus k is equal to 37. So now here minus 10 it becomes plus 10. So 35, 39. So k is equal to k plus 39 is equal to 37. K is equal to minus 2. Then the result of the value of k is minus 2 by using like this 10, 35, 39. So right. So k equal to minus 2. So from that like this. So this is the manner to find this type of question in section 2. Have you seen? Now third section we are going to learn the circle with respect to line. Now here the point with respect to circle, the point combination with circle completed. Next third section is a line with respect to circle. The line outside the circle or touch the circle or inside the and passing through the circle. That's the conditions in the third session. Okay.